If we have an index on the joint columns on one of our tables, the optimizer has the option of choosing another algorithm called the index nested loops join. Let's look at it here. The idea with index nested loops is that we take the inner loop of the nested loops join and we replace it with an index lookup. It looks like this. For each tuple little r in table R, and for each tuple little s in table S that matches, return the result of the pair. Now the magic, of course, is in that inner loop, where we only look at tuples from S that match. How do we do that? Well, we do that via looking up in an index. So for every tuple R, we take its joint value R sub I, and we do a lookup in the index on S sub j to find the matches. There may be many matches per tuple of R, so it is still a nested loop to form the pairs of R and S that match and add the result to the buffer. Now the cost of evaluating index nested loops join is a bit trickier than what we saw with our previous join algorithms. Roughly speaking, the cost is the cost of scanning R, and then for each tuple of R, it's the cost of finding the matching S tuples. But we have to deal with our various index variants of the alternatives and whether it's clustering or not. So, if the index uses alternative 1, the cost per tuple of R is the cost to traverse from the root of the leaf of the tree on S, which is usually 2 IOs from the height of the tree. A query optimizer usually knows the height of an index as metadata, so we can actually calculate that directly. For alternatives 2 and 3, we have to get the cost of looking up the leaf node, which again is 2 IOs for a B plus tree, and then the cost to retrieve the record from the heap file via record ID. And this, as we know, is different for clustered and unclustered indexes. For a clustered index, we do 1 IO per page of matching S tuples. And for an unclustered index, we do 1 IO per matching S tuple. This tricky bit here is that we don't know how many pages of matching S tuples there are for each of value of R. So let's work through this with an example. Here's our schema with table cardinalities shown. Note that there's an index on SID in the sailors table. So the unclustered cost is going to be the cost to scan R, and then for each tuple of R, we walk down the index and access the tuple. So that's bracket R, number of pages to scan it, and then for each tuple, R vertical bars times the number of matching S tuples, times the cost of accessing each matching S tuple, which is the cost of walking down the tree plus the cost of retrieving the actual S tuple. The clustered cost, on the other hand, is bracket R to scan R, and then for each tuple of R, we multiply by the number of matching S pages times the cost of accessing each matching S page. The access cost here is again the cost of walking down the index to find the matching page of S, where the cost is again the cost of walking down the tree plus the cost of retrieving the actual S page. Note the difference between the two costs here. One of them is based on a per tuple cost, while the other one is based on a per page cost. In our query, since SID is the primary key for the sailors table, so we know there is exactly one matching sailor tuple for each tuple in the reserves table. So going through some specific numbers here, if we have a B plus tree of height 2, Remember, that's going to be 3 IOs from the root to the leaf based on the way we number things in this class. Then the cost here for the unclustered index is going to be bracket R, 1000, plus vertical bar R, that's 100,000 times 1, the number of matching S tuples, and 4, the cost of 3 to walk down the index from root to leaf, and 1 for fetching the actual tuple. The cost for the clustered index is the same here, since we need to retrieve the single page containing the matching S tuple. In general, however, the cost of retrieving the matching tuples can be quite different. For instance, if a page can hold 10 tuples and there are 10 matching tuples total, then the cost for the unclustered index will be 10, the number of matching S tuples, times 4, the cost of accessing each tuple, while the cost for the clustered index will be 1, the number of matching S pages, times 4, the cost of accessing the page, which is quite a difference.